Hello all, this is Ralph Kubek. I see that it's 11:59 and we like to start promptly. But what we're going to do is we're just going to wait until about 2 minutes after the top of the hour. Happens to be noon because I happen to be in Chicago today compared to where I've been the last couple days. But we're just going to wait about 2 minutes. We respect everyone joining these meetings on time. The flip side is we know that in some cases, if you haven't been in a meeting recently, Teams, whatever, could take you a minute or two to get started. So I'm going to be silent. I'm going to go on mute for about 2 minutes, and we'll get started at 2 past the hour. This is Ralph Kubik again, and I am off mute. I'm sure people can hear me, and we'll probably have about 45 more seconds before my clock turns to 2 past the hour, and then we'll get started. Okay, on my clock, it's 2 past the hour, so we will get started. We appreciate people joining us today. The focus of the presentation is we're first of all going to do a little introduction, who we are, and then I'm going to lead a little bit of APS and why our focus, why Opcenter, the value of advanced planning and scheduling, what we're doing within the extensions of Acumatica, and then the flow of the data between Acumatica and Opcenter, and then Gabriel, who is on the line, is going to take us through a deep dive. Again, I'm Ralph Kubek, deal with sales and no longer services really, because a person by the name of Surrenda handles that. But I get involved in relationships, etc. Gabriel, who will be doing most of the driving today, is a solution architect related to what we are doing with planning and scheduling in Opcenter. Ablash is also might make a couple comments. Ablash is people have seen his face before, heard his voice before. He is in charge of product management for our solutions. For those of you who don't know who we are, we're Workplace Apps. We've been around the ERP industry for over 30 years. We created a relationship with Acumatica in 2020 to supplement their development and design resources with the focus of helping them fill in some gaps. There's been some other sessions regarding the customizations we've done in process management, other sessions on what we've done with quality. This is a session of a supplement of Smart Factory, which is really our APS solution, all designed and developed as it relates to the Acumatica piece. Clearly there's Opcenter within this, but all the Acumatica stuff is natively built. You can see we're pretty large in terms of the number of consultants and staff we have. We've gotten quite a few recognitions over the last couple of years. This year we were ISV of the Partner of the Year, Manufacturing Partner of the Year. We made President's Club. You could see Surrenda. This is the person that manages services. This is when we got the award. There's Ablash. I got called immediately after this award to say where were Sahab and I. Sahab happened to be out that day, and Acumatic had assigned me to do a speech at the same time. So fortunately, you don't have to look at my pretty face. What's our focus in why are we doing this? And that is Acumatica does have a basic advanced planning and scheduling module in it. But it needed to go further in terms of being able to do finite capacity planning, scheduling, etc. Some things that I will talk about, as well as Gabriel is going to go into a lot more detail on. Our focus was to try, or we are going to head to the point of being able to have as much of the scheduling information uh, that needed for scheduling within the Acumatica interface. You'll see how that's looking as I go into the product. We then want to be able to launch and operate a powerful scheduling tool. I'm going to oversimplify it, drag and drop, infinite planning, forward and backward from within the Acumatica framework. You'll see that, but some prospects now have asked, does it really have to be operated from within Acumatica? And the answer is no. We did want it to make it a seamless connection so that we just push data in and out. Which I'll review a little bit, and Gabriel will talk a little more in. And we are supporting both Acumatica's discrete and process manufacturing. In fact, it's further along with Acumatica's discrete solution than is our process manufacturing solution. Why Opcenter? And for those of you who are of my age or slightly younger, maybe have the amount of hair I have or don't have, Opcenter was an entity, was a product, was an entity at one time that was called Preactor. It has been bought by Siemens, and it's now titled Opcenter. Why did we choose that? It's been an industry leader for many, many years as it relates to manufacturing with advanced planning and scheduling. It had a whole host of algorithms and analysis that could be done and constraint rules. Candidly, things that would take years for someone to develop, and we wanted to leverage best of breed technologies out there. We wanted to be able to have the scheduler evaluate multiple scenarios. When I do these demos, I'll talk about the planning board being a Ouija board, right? I'm the scheduler. I drag and drop things. I play games, and then I finally publish it. We also clearly, from an operational end, wanted to be in a situation of where you knew how to balance capacity and what you need to do. In terms of scheduling, right, there's a planning piece and there's a scheduling piece. The focus of APS is both. It's going to let us know what we can make and when and how much. You'll see some ties into, do we have the material? Do we have the right resources? And then the other part is, how are we going to best synchronize these? How does we handle priorities? How do we handle constraints? How do we manage changes in the schedule? Potentially, how do we sequence? We might want to sequence on the order priority, something that you can do within Opcenter today is, maybe I'm a paint manufacturer, and so I want to schedule this going from light paints to dark paints. Those are all things that you could do within the system, all core elements of how the Opcenter engine was built, which is why we wanted to rely on that engine. The real value proposition as it relates to pulling in Opcenter, as it relates to Acumatica, is this ability to have a tool that supports the tactical decisions. What should I make? How should I make it? How I could best make it? Helps to predict uh, things as it relates to potential interruptions or scrap, or for sure allows you to react to those uninspected changes. Gee whiz, a machine just broke. What does it mean? Uh, Computing, real-time efficiency, and then supports decisions, right? Do I need to bring in do I have to work a little bit of overtime? Do I maybe need to group things together to reduce the changeovers and different problems and different things that might be out there from a scheduling piece? Advanced scheduling, when we look at it holistically, it improves customer service. We now have better on-time deliveries. We're on time because maybe we could better predict when we're telling a customer that it's going to be ready. We could be more agile. We can reduce WIP. We could have productivity improvement because we see all those interactions, and we become lean. We could better plan material, right? If we don't need material to the fourth step of the operation, and that's going to take 6 weeks, we shouldn't order it now if it's only a 1-day lead time. So we could reduce raw material, we could reduce cycle time. And again, we are able to synchronize both the planning and the control process. This is in Acumatica, so I'm going to skip a little bit. That's the overview of why we've done this. And now in terms of Acumatica, as I indicated, what we want to do, what the focus is to try to do as much as we can within the context of Acumatica. What does that mean? That means that we've extended the Acumatica bill of materials screen to address alternate work centers. It could be tools. It could also be positions has been retitled to either individuals or skill sets. Again, getting to the point where this is the information that the scheduling system needs. This is things that the engineering team has put in place. It's not necessarily what the schedulers. So is those engineers, as those people are putting things together, let's keep them in the Acumatica interface. Let them put into the Acumatica interface all the information that a scheduler would need, and then let's push it into the scheduling system. Important as it relates to, again, alternate machines and work centers. The other part of this, I'm sorry, I copied the wrong screen in here. Oh, this isn't allowing me to go backwards. What is going on here? Hold on here. Go back one step further. Previous. I thought I had copied in the Acumatica production order screen, and on the production order screen, what you'll see is we have start times and dates, right? Acumatica is date specific. Clearly, when we get into production, show you the actual time that's going to be working. In terms of the data flow, what we're trying to do is to make certain that resource information, alternate work center, some of the constraints as it relates to tools and positions are all within Acumatica and get pushed to Opcenter. The demand, customer orders, production orders, bills of material, stock, all those are things that need to be pushed into Acumatica. The data flow from Opcenter back into Acumatica is after someone does their scheduling. As I mentioned before, after someone firms up their Ouija board of how they have done their scheduling, what we're going to do is going to make that schedule firm in Acumatica. We're going to update the routing, the production order if we've done some things to move around work centers, etc. Clearly, what I just indicated, we're going to be able to have now within the Acumatica infrastructure, start time, end time, setup times, all things that now when the production person goes to do their work is all within the Acumatica framework, all within the realm of Acumatica reports. What happens is this part, we just created a new menu choice. We are able to deploy, and we're doing Gantt within the core of Acumatica. We then are able to launch advanced scheduling from this. And this is the two simple buttons that someone needs to push. I need to go ahead. I'm going to begin to do scheduling. You'll just click this button, and anything that Opcenter needs is immediately going to be pushed into Opcenter to do scheduling, as Gabriel is going to start talking about in about 2 minutes. When they're all done, that scheduler just has to press another button that says, okay, bring all of this back into Acumatica. So integration points are really just those two buttons. So with that, we're going to see APS in action. And what I'm going to do is this is the hard part for me. I'm going to stop sharing my screen. And Gabriel, you could begin to share yours, and and you're in charge for most of the rest of the session. At the end, I'll just come back for thank yous and a little bit of recap. Gabriel, it's all yours.
Thank you, Ralph. I just don't have the permission to share my screen. I think you need to give it, isn't it?
Oh yeah, I think I have to change presenter. I think I just changed presenter. Oh, I'm going to say yes. And now you should have the ball.
Okay, it didn't give you the option to which screen you're sharing. Which one is it showing?
If you under show, there's a drop down box that says screen that you could, you'll be able to pick the screen that you'll show.
Okay, but which one are you saying? This one with Opcenter now, or?
Yep. What I'm seeing, you just dragged it on. I see the Acumatica interface that's pushing the data into Opcenter.
Okay, thank you. So, good afternoon, everyone. I'm Gabriel. I'm going to be presenting the Opcenter piece here, the Siemens Opcenter piece of the presentation, the demo. But I just would like to begin first with exploring this integration concept that we have with Acumatica ERP. So Siemens Opcenter is part of the Siemens Manufacturing 4.0 portfolio of products, and APS, which means Advanced Planning and Scheduling, is one of the main parts of this portfolio when we want to move forwards Manufacturing 4.0. It is the global leader of APS, or one of the global leaders. It's over 8 different countries, translated to different languages, implement 1,000 times. And if we do a research, we're going to see that Siemens is that answer for APS, and that is why we choose here to adopt the Siemens Opcenter as our choice. But why have this seamless integration, right? When we look to an APS implementation or another large system implementation connect with our ERP, we can face long implementation times. We can face a year of implementation because integration costs a lot of time, costs a lot of money. So we have developed this seamless integration to reduce the implementation time and reduce the cost of every project. It becomes a win-win for us and for you. Another challenge that we literally face in new APS project is about how we manage the data. Our APS system is a eager dog. We need a lot of variables to digitalize our manufacturing process and make decisions. So, and when we look sometimes to the ERP, we don't find all the availability to define all these variables, all these different fields in our routing definition, in our demand, in our supply, and so on. So we have been empowering, creating the ability in Acumatica to redefine every single variable in the ERP. And then we don't depend on third sources of integration, and we know that our process to maintain the data will be centralized in the ERP. So that is key. That is really really manage the APS as a perpetual integration solution with stable documentation, stable integration, stable process to follow. So that is a great advantage that we offer when we bring it inside of our Acumatica portfolio. Well, speaking about the APS, so as Ralph just mentioned, we have here the main screen, the beginning screen, where we're going to see that we have the option to import data, to release data, and to generate schedule. And basically, before we start to make any decision in the scheduling scenario we're going to follow in the shop floor, we need to take a snapshot from our data. If we are putting together a puzzle, we don't want the pieces to change the format, right? So we take a snapshot as is right now, our production orders, our demand, our supply, everything. and then we decide the scheduling scenario. Once we decide the scheduling scenario will follow, we release it back to ERP to that guide the shop floor operators for execution. But let's see that. So Accent generate schedule. The first screen we're going to see is the Gantt chart, the one in the middle here. And just explaining the objects we're going to see here, on this axis, we'll find our machines or work centers that would depend on which kind of primary resource you want to schedule over work centers or over specific machines. And each of those machines has a calendar availability. So, for example, it's a generic demo. We have machines only with numbers here. We have a timeline on the top. And for example, if we look for the representation on the Gantt chart, we see that this machine is working in this white area. Then it has an off shift. For example, during the night, we are not working. Then it works 2 shifts again. Then we have a night shift. And then maybe we have the weekend where we're not working. The research 4, we are working only 1 shift. See that it's quite longer, the shift on the other machines here. And then here we have 2 white zones. Let's say we have part of our shift before launch, we stop to launch, and we come back to work. And then on 14, it's working exactly as we work in the other machines, 2 shifts. So what I want to say, what I want to represent in explaining these calendars here is that we can define specifically the calendar for each machine. And the calendar of each machine will define our finite capacity. And that is the goal, that is how is format, how is built the APS solution. It's not as a MERP that creates a schedule list, let's say like that, or a dispatch list with infinite capacity. Here we want to schedule our operations over the limit of time we have to do that. So a calendar of shifts can be a cycle, right? We have a shift that repeats itself every 7 days or every 14 days. We can have different representations. We can have a transaction from one shift behavior to another, like here, from 1 shift to 2 shifts. We can specify, we can model any of that in the APS solution. But we have another events that also can reduce our finite capacity. We call them special events, such as if we look here to the research 1.1, we see that we have a different representation, visual representation here. That is this origin wall. That is, in this example, in this demo, that is a planned maintenance. So if shift is cycle, is repeating itself every time, we are able also to specify what's not repeating, right? What is going to be one time or a recurrence of a planned maintenance every 3 months, every 2 months. So we can define exactly that events that where or when we also will not be able to manufacture. Could be vacation, could be the appointment for our labor that they are not going to be available, could be the plant maintenance, could be a breakdown in the machine happening from now, or could be also a production behavior. We could specify extra time, overtime, if we have late orders and we want to have more capacity, we could specify our overtime here. So we can model that finite capacity specifically for each of our resources. And that finite capacity we are going to use to schedule our production orders. So I'm going to open another screen here in the left. I'll fix it here. And those are the production orders operations that we just imported from the ERP, from Automatica. course, for demonstration, I'm starting here from an empty Gantt chart, but imagine that if you are using it daily in your scheduling process, you'd start from some orders already scheduled and would schedule the new orders or would change the sequence of the orders. But those production orders operations, as I was saying, it is what's going to use this finite capacity. Let's understand how it works here first with a drag and drop, and then we can have example of automatic scheduling generation. So I would drag and drop one of these operations and see that I can drop it in the resource 1, in the resource 2, but I cannot drop it in any other resource. What is defining that is the Acumatica routing, the Acumatica bill of material. We're telling there that we have some execution time, that is the colorful area of this operation here, and we have a setup time or a changeover time, that is the dark area here. So we're saying in the resource 1, I have 1 hour of setup time and 1 minute per 1 minute per unit that I'm going to manufacture, or 100 minutes per batch. We can find exactly how is the process time of it. So every operation here, it will be respecting the definitions of routing of manufacturing process from Acumatica. And like that would consume the finite capacity. But we don't want to do that manual. We don't want to manually drag and drop every operation here. We want to save time. We want to invest and focus our time analyzing the scheduling scenario. So let me unschedule it. And let's start to speak about the nice things about generating a scheduling automatically. To generate a schedule, to generate a scenario, we need some strategy, right? Every industry has its own business strategies that they consider in the scheduling routine. And we can kind of translate here first as a simple scenario, saying that we have a scheduling direction that could be forwards to have every operation read as soon as possible. Or we could schedule the production orders backwards. That would be kind of adjusting time to have the end of the operations as close as possible with the demand. And then we could have complex scheduling rules, but let's focus first in these two directions. After decide the scheduling direction, we need to say what is the scheduling criteria. So we could say we're going to schedule forwards as soon as possible. By due date, every production order has a due date we want to complete. Or over priority, we can define in Acumatica a priority number for each of these orders based on customers, based on projects, based in products that are similar, and so on. So let's start with a scheduling scenario forwards using the criteria due date. Defining that, we only need to click in generate schedule, and every unscheduled operation will take place in the Gantt chart, consuming that finite capacity, that calendar we just defined for the resource. Then we can start to speak about another variables that we want to be sure the APS is respecting, that we want to be sure that the APS is building a feasible scenario. So I will highlight a production order here. And when I do that, the system shows the relationship of the different production orders operations. And to explain that, I will unhide another screen here on the right. That is the operation properties. This screen tells me what means the colors inside of every production order operations. The user can create endless views or profiles to change the colors of the operations. Right now, the top color in every operation here means the product part number, and the bottom color means the order number. We have those texts inside of the operations, as we can see. It's the part number, the order number, and the operation number. So we can edit it. We can create the view we want to make easier to analyze, to validate the scheduling scenario. So following these colors here, we can easily understand that it's a production order with 4 different operations, 3 different resources. We see the relationship between the operations. It's respecting, it's not starting any operation before the previous one is completed. And that production order depends on 2 intermediate products that the synchronous is also respecting. And either the finished good as the same finished products here, they have dependence with supply. So in this case, it's using raw material from stock to manufacture that, to manufacture the production orders. The supply is represented by these milestones, so we can understand we have stock here, and we have, for example, purchase orders arriving in the future of our timeline. And in the bottom, completing our highlighting our relationship map, we have the demand, where we can see the sales order or forecasts that the finished good production order is linked with. So we see we have a sales order here that's late. It's red, the color. And we have another sales order for the feature that we are delivering on time. The relationship, the times, like here we are saying we cannot start the next operation before the end of the previous one. We can create, we can define harder rules or harder variables for minimum time, maximum time, right? For a paint dries off, for example, or if you are from food and beverage, we don't want to a semi-finished product to expire, to goes off before we do the next. So we also can specify that rules in the routing in Acumatica, and the scheduling engine will automatically consider that when it's creating the scheduling here. If we have a minimum time, it will not allow to start the next operation before that minimum time. Another constraint here, we were highlighting an order that depends only on supply, but another constraint we can have in our process is about supply. We don't used to have we used to schedule a horizon of production orders that is greater than the material we have in stock, and we need to consider the arrivals of the purchase orders in the scheduling process. So, for example, this production order I'm highlighting here, see that the first operation of the finished good depends on the purchase order. So the system automatically doesn't allow that operation to start earlier because we need to wait that purchase order to arrive. Also, speaking about supply, we have the production order 15 that is on schedule. That production order, if we look that in the, let me show it in another way. If we check the material condition of that production order, we can know that that production order is in shortage. It's missing some material. We cannot schedule it because we need to place a purchase order to it. We can also check that situation through reports. For example, we can access the supply order report. It's just generating the report. 1 minute, rendering the report. And the report will show us that we have some orders with stats on time, all right? But we have some orders classified with stats shortage. And we can easily understand that the production order 15 has a shortage for the required material specific code, what is the quantity, it's shortage. So see that our scheduling scenario is really feasible. It's not allowing any uncontrolled situation, any constraint it's respecting every constraint we have defined in our data in the ERP. We have spoke about finite capacity of machines here with the calendars for each machine, but it's not only machines that maybe we need to consider in the scheduling decisions. Maybe you also need to consider labor availability or tooling availability or space, energy power consumption. So we are also able to model or define those other harder constraints. So here I'm changing to another screen, that is the plots screen, and see that we have plots to different secondary constraints or to different operators and tools. And for each of those, we also can define a calendar. We can say how many operator one we have, right? There is this red line here. Here we are saying we have 2 all the time, all the shifts. And let me combine it with the Gantt chart. And the colorful area of every plot will mean when we are using that secondary constraint, when we're using that labor. We can, for example, click here and see what is the production order that's using that 2 labors at that time. And see that never we have the consumption of any of these plots crossing the red line, because we are also respecting the limit of the availability of them. Another feasible variable for us. So we have spoke about the relationship between the objects, right? That's respecting the synchronous, that we are able to see the demand that's late, that we are respecting the supply arrivals, that we are respecting labor and tooling. But now maybe even that we prove that's a feasible scenario, we need to remember that we just generate a scenario, a generic scenario here, forwards by due date. And even that you have a strategy in your industry, maybe you don't want to every time schedule with the same strategy. You want to see what would happen if you schedule with another strategy. So every scenario, this scenario here, we schedule it over due date. For example, I can change the operation properties, the colors of the plot, and change it to due date. I can easily see that the earliest dates are the first, then I have the ones for 21, and for 28 I have only that one that is with a shortage. But maybe, for example, I have another set of priorities set in the ERP, right? I have different numbers of priority for the orders. And this scheduling scenario that is considering due date, I can check what is the scheduling statistics from the scenario. So I can see that on that scenario, I have 2 late orders. I have a total setup time of 5 days and 12 hours. I have a total lead time for the horizon for the entire scheduling scenario of 29 days and 20 hours. I projecting the utilization of the machines of the resource in an average of 29%. So I have a bunch of data here that I can understand how is the performance of that what if scenario. And I can now try different strategies. I can unschedule it. I can change it, for example, for priority, my criteria, keeping scheduling forwards by priority. I can very quick generate a new one. Again, I know it's respecting all the feasible variables, respecting all the constraints. And I can come back and check the statistics. Now I have only one late order. Maybe I increased or decreased the total time for setup and lead time. Maybe I increased or decreased the resource utilization. So I can be creating endless scenarios here. I don't want to schedule I don't need to schedule every resource with the same scheduling rule. I don't need to schedule the full horizon with the same strategy. So here is where the user will start to do their things, right? We start to check, to create different scenarios and see what would happen in that way. And every scenario we can save with a different name. So I can save a copy of every scenario, and then I don't going to lose any of these stats. Then in a meeting later on, I can present to everyone what is the outcomes of each of these what if scenarios, and together as a team we can decide the direction we're going to take. But now I want to show, after speaking about what if scenarios, I want to speak about more advanced scheduling rules. Those ones are more simple, right? Forwards by due date and priority. Now I want to speak about something that is very common to see in customers. That is, for example, setup optimization or grouping similar products. So I will change the view, the colors of the Gantt chart now for one view create code attributes. And we can see that these two resources, that they are alternative resources, they are clearly the bottleneck of our process, and is exactly in this operation that we have some attributes defined as the tool, the product operations use, the material type, A or B, and the color. It's very common. It's not always, but it's very common that when we are manufacturing, and maybe if you're going from dark to white colors, or from one kind of material, or changing the tool or not changing the tool, we can be saving changeover times. We can be reducing changeover times depending on the multiple possibilities of sequencing scenarios on the machine. So we can have simple logics. If I change the tool, I have 1 hour, or we can have matrix logics. If I change from 2-1 to for the 2-2, I have 2 hours. But if I change from 2-1 for 2-4, I have half hour. So there we have the opportunity to optimize the setup time. So let's try it. The way we build this demo here is for an industry that would have that kind of situation. So I will basically unschedule the operations. I will apply now one rule that is the advanced scheduling rules for optimized setup time, and it will generate a new schedule. And then I can decide even what is the horizon that I want to apply that setup optimization. For example, I want to optimize every 15 days, right? Or I want to optimize in 30 days. I want to optimize it every week. So that will depend on your process. If you are make to stock, if you are 50-50 make to stock and make to order. So we need to understand exactly what you need to advise you what to use. Here I'm going to make an example of optimizing a horizon of 30 days. And we already have a new scenario. If we look maybe by colors, we can kind of already see that's grouping the similar attributes. But the easiest way is, again, check the statistics. And of course, for the demo, I have prepared a comparison here, just be easier for us to analyze. So the first scenario, it was forward by due date. I had 2 late orders, those 29 days lead time, 5 days setup time, 27% of machine utilization, resource utilization. On the last scenario of setup optimization in 30 days window, we increased the late orders, we reduced the total setup time and total lead time, and we increased the resource utilization. So when we start to compare the what if scenarios, we start to see trade-offs. We have gains with the what if scenarios, and we have losses. But the strategy point here is very fast to create it. Now I could create a 30 days of setup optimization, a 7 days. I could have 7 different what-if scenarios, and then we can decide what is the best direction to take on the next days, on the next weeks, on the next months. That is the power that we want to deliver with the APS. Invest the time analyzing the scheduling and not validating the scheduling, building and validating it. Okay, before I finish this demonstration, I just would like to speak about 2 important topics. One is when we decide the scheduling scenario we want to follow, we'll just save it, and even that we already have a dispatch list inside of Siemens Opcenter, we would basically release it back to the ERP, and the shop floor operators, the supervisors, everyone could follow the plan start and end date and time for every production order operation. The other situation that I want to speak about, and for that let me create a scenario here. Let's get by forwards again and choose due date. Is after we release a scenario, something is what we plan, another thing is what is actually will happen in the production, right? We cannot control some situations like a breakdown in the machine. So let's think that after we release that scenario, the hysteresis 1.2 broke. So you can report that in Acumatica. I will make that change here just for our demo to be faster. So I'll say that the machine is in a breakdown situation. Let's say at least for 2 days, it's a very bad one. See that it's already create that event in the calendar. And now, if we highlight the operations, we don't have a feasible situation anymore. We are finishing that operation after the beginning of the next operations. So we cannot continue with that. We could unschedule and schedule again, maybe that would fix. But if you don't want to change everything, unschedule and schedule, we have also the possibility to repair. So we can click in repair, and then we can choose if we allow sequence change, maintain the sequence when possible, or prevent any sequence change if you don't want to any order change place with the previous one. So I will prevent in this way. I'll click in OK, and our schedule already got repaired. If I highlight now the same production order, we can see that now it is in sync again. And then we can check what are the sales orders that got late with that, what are the impacts that this breakdown just caused us. And based on that, we can ask for urgency for this repair, or if we have no big impact for us, for our main goal, that is deliver on time and full the sales orders, we can just accept that situation. That's just a piece, just a part of what we can do with Siemens APS Connect with Acumatica. Of course, we have much more. We have even different variables that we could consider in scheduling. But due to the limit of time, I'd like to finish the demonstration here and open time for any question and doubt that you might have. Thank you very much for your time.
Thank you, Gabriel. What I'm going to do is I'm going to go back and reshare my screen. So I'm going to make me presenter. And then I'm going to share my screen, which should be the PowerPoint. This is the beginning. This is going to be a long road. Like every product has a long road in Acumatica's cycle. The The focus is we want people to stay within the Acumatica framework as much as they can. So we're working on Gantt charts and other things to just be displayed within the Acumatica framework, so people would not have to go out to Opcenter. We're working to see what we could do to sync scenarios with Acumatica, and then under calendars, and there's going to be a list that's going to continue to be added there, a list of again, things that right now is Gabriel showed you the updated calendar within the Opcenter, but again, we're going to try to move as much as we can into the Acumatica piece. Questions? There was a question as it relates to Opcenter. Opcenter is an application that will have to be hosted. So part of the pricing infrastructure is the cost to the hosting charge, where Opcenter's there. I don't know, Gabriel or Ablash, if you want to make any comments about just the architecture of Opcenter, but it is an application that to some extent is installed, right? It's not installed in the cloud. It's going to be have to stop on a server. But again, we are including that within the cost of the product offering. So there was another question that came in, and that relates to our support of this. We are to the point of looking for early adopters, that people that need a tool like this. We're prepared to begin to work with you on that item. Another question came in, someone that obviously knows a little about Siemens Preactor, and that is there's different levels of Siemens Preactor, and it indicates what level we're supporting. We're supporting the base one now, and one of the things that Gabriel and the team that is going through the due diligence, gathering information is to find out what feature exists where within the Siemens Opcenter versioning that they have, and we'll again continue to make certain that we're communicating what we can support not only within the Preactor engine, but also how it relates to the different levels that Preactor has. So those are the questions that came through. Hopefully we've answered those. Again, we appreciate the time that you're spending on this. As you have questions, feel free to reach out to your partner. If you're a end user, and we will coordinate things with your partner. If your partner, reach out to us. Another question just popped up, and that is a couple things here. It says, what version does this work with? It's designed to work with starting with version 24 R1, and then move forward just like we have before, although we're prepared to support this on 23 R2. So the early release would be on 23 R2, but our focus of making this formal is with 24 R1. And there is another one in here. I'm just going through the questions. So 24R1, 23R2 is when it's going to get released. And I'm reading through the comments. I think that answers the question. Oh, that it is designed to, again, support both Acumatica's discrete and process manufacturing product. Again, we're further along with that. I see the last question was, do you need Acumatica APS to use this? And the answer is no. This module would replace the Acumatica APS Advanced Planning and Scheduling solution. So that's the end of the questions. We usually try to leave about 10 to 12 to 14 minutes for questions. I think we have gone through the questions. Gabriel, we appreciate your help. Again, feel free to call and write. And with that, we'll conclude a little earlier, so we'll give everyone 5 minutes of their life back. Thanks for attending, and look forward to future conversations.